ஒரு எக்ஸாம்பிள் ஆஃபீஸ் இருக்குன்னு வச்சுங்க, இல்லை உங்கள் வீடு இருக்குன்னு வச்சுங்க. என்ன பண்ணுவீங்க, உங்கள் எல்லா திங்ஸையும் எங்கேயோ ஒரு இடத்துல போடுவீங்களா? இல்லை, அந்தந்த திங்ஸை அங்கங்கே வைப்பீங்களா? அதே மாதிரி உங்கள் file, suppose when an office, if a file is going to organize, example n number of details regarding sales report, production, okay, and how much sales has been done this month, and what are the buyers and the customers are there, and how much they purchased this month. All those things, the details will be there in case of a office. And what is the tax rate for distributing the product? All those things will be maintained in that particular office. Now, what we are going to do? So, எல்லா டீட்டெயிலும் நீங்கள் you are going to segregate. சரியா? இந்த ஃபைல்ஸ்லாம் நீங்கள் எல்லாத்தையும் ஒரு இடத்துலயே கரெக்டாக அந்தந்த பொசிஷனுக்கு நீங்கள் வைக்க போகிறீங்க. ஓகேவா? So, you are going to segregate all the files in a particular place, and you are going to maintain that. So, whenever the data is needed, you are going to take that file. So, for that reason, what you are going to do? You are going to collect all the files. நீங்கள் என்ன பண்ணுவீங்க, எல்லா இடத்துலையுமே அந்த relevant data என்னென்ன இருக்கோ எல்லா டேட்டாவும் நீங்க கலெக்ட் பண்ண போறீங்க. So what is the relevant data? How you are going to collect? So that is the data which is stored previously, and those data you are going to get whenever is needed. You are going to get the data and collect as a files. Okay va? So first எல்லா டேட்டாவும் நீங்க ஃபைல கலெக்ட் பண்ணிக்கிறீங்க, right? After collecting the set of files, what you are going to do? You are going to split out in the as a sequence of records. So now, what are the sequence of records? So if a file is there, right, for that one, each and every record, there will be an index. So these records will be maintained based on the record number. Okay, record number. So each record number, each file, each record will have a record number, and based on that, it will be aligned in a sequence form. It will be aligned in a sequence form, right? Now you have aligned எல்லா டேட்டா கலெக்ட் பண்ணிட்டீங்க, அந்த ஃபைல்ஸ் எல்லாம் கலெக்ட் பண்ணி அரேஞ்ச் பண்ணிட்டீங்க. செகண்ட், ஒரு செட் ஆஃப் ரெக்கார்ட்ஸ் இருக்கு, அதுக்கு வந்து ஒரு ரெக்கார்டுக்கும் ஒரு ரெக்கார்ட் நம்பர் கொடுத்துட்டீங்க. ஓகேவா? you have given one record number. Now all the records are in a sequence of fields. So எல்லா ரெக்கார்டும் வந்து இப்போ அடுத்தது நெக்ஸ்ட் வந்து you are going to do the sequence of fields. ஒரு ரெக்கார்ட்லயும் அந்த ஃபீல்ட் என்னென்ன இருக்குன்னு தனித்தனியா ஸ்ப்ளிட் பண்றீங்க. ஓகேவா? So these are the three main things which you are going to do in the file organization. Okay, so first one is the particular file organization. We are going to store all the data as a collection of files. Okay, next, each file என்னென்ன ஒரு சின்ன ஃபைல் இருந்தாலும் what you are going to do? You are going to give a record number. ஒரு ரெக்கார்ட் நம்பர் நீங்க அந்த பர்టిక్యులர் ரெக்கார்டுக்கு நீங்க கொடுக்க போறீங்க, ரெக்கார்ட் நம்பர். ஓகே, so you go into record number. So based on the record number, there will be a sequence of records. Okay, there will be sequence of records, 0, 1, 2, 3 and all. Okay, so sequence of records will be maintained, and these records is a sequence of fields, right? So okay, sequence of fields. Now what happens? Every record is going to be in a sequence of fields. So how it will be sequence of fields now. Record 0. Suppose just assume that I am going to take a record 0. So after taking the record 0, what happened is I will go with the sequence of fields. Now each record having different fields. Each record have different fields. Okay. So like this, I'm going to have file organization. Okay. So in your house also, what you will do, you will put a table, chair, sofa, bedroom, and the kitchen utilities and grocery item in one place, and lavatory items, lavatory places. Okay, all these things, what you are going to do, you will set as a map, okay, or a blueprint, and you will design based on that one. What are the things to be kept and which place, and what are the use of that one, and based on that use you are going to keep it in a different places. Okay, so like this you are going to segregate and order that arrangements, and you are going to organize all the materials or the products in your house also. Okay, the same way here also in the file organization, you are going to have a collection of fields. Okay, collection of fields, collection of sequence of records, and a sequence of fields. Okay, right. So this is called as file organization. So it will surely come in MCQ, just make it note. Okay, next classification of records. How we are going to classify? One is fixed length and another one is variable length. So fixed length ன்னு சொல்லும்போது அதோட சைஸ் தான் நம்ம பார்க்கணும். ஃபிக்ஸ்டு லென்த், அந்த வேர்டோட மீனிங்லேயே நமக்கு தெரியும். ஃபிக்ஸ்ட் லென்த்னாக்கா பேஸ்ட் ஆன் அ சைஸ், based on the size. So what size it is and how much data can be acquired based on this, and what are the facilities available to acquire these data, and how much size or volume of data can a particular record can hold. Okay, what are the different types of account which you are going to hold? Ellame neenga you have to have an assumption also, as well as how much record it's going to what is the capacity of that particular record, how much the record it can handle. All those things you have to see. Okay, Mama. So like this, the classification of a records, that is fixed length record and variable length record. There is a two classification. So as we said, fixed length record la enna irukum, it has size of fixed each file, adoda size evlo size, adoda capacity, volume. Okay, we are going to see that one. So in the volume, size, capacity, இதெல்லாம் வந்து ஒரு ஃபைலுக்கும் ஒரு டிஃப்ரெண்ட் இருக்கும். So each different file will have a usually a different record size. Okay, each file will have each size with a different record set. Okay, that is record size. So if you are seeing that one, you are going to have a fixed length record approach. So this is how the fixed length record approach will be applied. Okay, next. So as we said earlier, so there are set of record numbers. So under a particular each file is a sequence of record. அப்படின்ற second point பார்ப்போம். So on the second point each file has a fixed number of record. அப்படின்னு பார்க்கும்போது we have different set of records. So அங்க அந்த second point என்ன சொன்னோம், what we have said in the second point, each record having a sequence of record. The file, each file is a sequence of record. அப்போ each record will have a record number. Each record will have a record number. That is the sequence of records will be allocated. அப்போ the record number மூலமா தானே record வந்து having a sequence of alignment. So like that we are having record 0, 1, 2, 3, 4, 5 and keep on going. Okay, so based on this record number, so you're going to, the file is going to align in a sequence, form. Okay, so record 0 ku a set of a record will be there. Okay, record 1 ku a set of record will be there. Right, now if the record is aligned like this, now each next one on the record is a sequence of fields fields. Okay, so upon each field is going to take some sort of bytes. ஒரு record ஒரு some sort of bytes. You're going to take some set of bytes in that one. Now what this byte will be, each record will have a fields. Each field in a record will take some bytes. Okay, so how much byte it going to take and what is the length of the record and what is the size of the bytes, all these things will be calculated. Okay, so in that case assume that field this these are the 3 fields. Okay, 3 fields and the first field assume that it is a number character, so it will take you 10. So here it's taking 10. Now next one, branch name, so it is a character with 22 bytes. So this is the branch name, so this will take 22 bytes. Now and the last one is a numeric, how much balance, so numeric will take 8 bytes. Okay, so this is the assumption. So 10 plus 22 plus 8. So this is how the total bytes for a particular record, total bytes for a particular record is calculated. Okay, total bytes for a particular record is calculated. Now how much this one is, if we sum up these 3 bytes of the fields, it will be around 40. Okay, so if this is the case, so each byte of the record is calculated based on this sequence of fields. Okay, so the field having different fields of a different record having different size, that's only we have told. Different files are used for different records. So based on the size, how we are going to have, we have assumed that record size is fixed. Okay, assume that the record size is fixed. Now how it will be fixed? So based on this fixing method. Okay, record access. So using the pseudocode, we are going to take the size of the characters, I mean the size of the bytes of each particular field, and we are going to have a sum of this field. Okay, so this is how we are going to check with the fixed length record approach. Right, next, so we have a similar thing. One is block. So how the blocks or different records will be there. So in a particular database, there will be different block. So what the block will do, it will save all the record. So one block, it will save in one block. Okay, partially the record will save in one block and partially the record will be saved. The same record will be saved partially to the next one. Okay, so like this we can have different difference in the both the saving of the particular record. Now if I want to read this particular record, okay, if I want to read this particular record, I will read using the axis of read and write. Using the axis of read and write. Okay. So I'm going to use the read and write to read both the block. Read both the block. Suppose I want to free up the alternatives. So I want to link all free records. So what I have to do, I have to segregate the free records in one side, and there is a filled record in one side and a free record in other side. See, this is the method. I can link all the records, the free list, or which is filled into one side. So based on this, I can finally record to delete the particular record. So move all the records to one place to another place. Okay, so this is how I'm going to save all the records using block boundaries. So there is a block boundaries. So each database will have a blocks, and it will be saved. The files or records will be saved partially in one block and partially in another block. Okay. Now, so this is how it will be seen. So first, we are going to see with the address of free list. So free list we are going to see. So first record in the file header. So it store the record header. What it's going to do is the record header. What it's going to do? It stores the address. Stores the address of the first deleted record in the file header. So it stores the first deleted record in the file header. Okay. So here, can you see this one? I have deleted the record, and it stores the first deleted record in the file header. Now, what I'm going to do is then it stores the second deleted record. Then it stores the second deleted record and the third deleted record. Like this, the deleted records will be stored in the header. Okay, so for file header. So the file header will contain all the record numbers in a sequence. Okay, so now I can split up the free spaces as well as the deleted spaces, okay, easily by using this set of activity, by splitting up the records numbers and assigning the address and so on. Okay, so this is how I can delete the record from the file header. Okay, right. So here also we can have a variable length record. So what are the different variables? Using different variables. So this is the end of the record where it can be attached a control character. So this is the control character. Okay, character at the end of each record. What I am going to do, I have to attach at the end of each record. So if that is the case, this is the record number, and at the end of the record I have to attach end of record like this. So this is the control character. Okay, so for a particular record. So here also in record 0 I have ended, I attach this end of the record. So in the second also I have attached the end of the record. So what is the main advantage and disadvantage while considering? Advantage is somewhat okay. Mainly disadvantage is reuse space. So it is not easy to reuse this particular space. So can you see after this control character there is some space. So that space cannot be reused. That space cannot be reused. So that is the main disadvantage of this variable length record. So inserting all the control character after a particular record field. So that is the we cannot use this particular space again. Okay. Next, so slotted page structures. So how this slotted page structure is going to help? So I'm going to check with the each free space using block header. Okay, so and I want to check the entire free space using different entries. So how does the end of this free space, I'm going to check with the entries as well as size and the location of each record. Okay, size and location of each record. After that, I'm going to split this record, okay, as a separate segregation. So one side is a P record, that is P space records, one side is a filled record. Now at the end, I will have a end of free space, how much space I have. So this is called as slotted page structure. So same as there is another one, pointer method. So for each record 0, 1, 2 and 3, I need to have a pointer where the address of that particular record is stored, and you are going to have a list of fixed length record having chained together via pointer. Having chained together via pointer. What is called a chain? It will have a link via the pointer. So you know what is called pointer, and what is the address of the particular point. Through address of the particular pointer, it will link. Okay, like that, you are going to have a list of length record having a chained together via pointer. So the main solution is to allow two kinds of block in the files. So assume that there is one block and the block is there. So it will have a link with this particular length of the record with the chained together. So like this, it will be chained from one block to another block. Okay, using the address of that particular record. Right. That is called as chained together via pointers. So it allows two kind of block in a file, that is anchor block and the overflow. So anchor is the first record of the chain, and overflow is the first record, that is contains records other than first record, those the first record of the chain. So this is the main difference between this one and this one surely comes in the MCQ. So for the first fixed length record having a chain together via pointers. So that due to this, it can link with from one block to another block easily. So two block in a file, it can have the solution. Okay. Right. So we will have a video session also. So what is called RAID and file organization. Okay.
Storage is a very important part of fault tolerance. If something were to happen to a company's data, such as a disk failure that results in data loss, then that could have a serious impact on how the company performs. That's why we need to make sure that if a disk does fail, that no data loss would occur. And one of the best ways to prevent data loss is RAID. RAID stands for Redundant Array of Independent Disks. In a RAID setup, the data is copied on multiple disks, so that in the event of a disk failure, no data would be lost. Now there are four common types of RAID. There is RAID 0, RAID 1, RAID 5, and RAID 10. Now RAID 0 is not fault tolerant. In fact, RAID 0 shouldn't even be called RAID, because not only does it not provide fault tolerance, it actually increases the chance for data loss. Because in a RAID 0, the data is not duplicated, but is actually spread or striped across two separate disks. Hurt yourself with a hammer, then all the data would be lost. So the only reason why you would want to use RAID 0 is speed. Because when you have two disk controllers working instead of one, then accessing data is much faster. Now, RAID 1 is fault tolerant. In a RAID 1 setup, the data is copied on more than one disk. So disk 2 would have the exact same copy of the data as disk 1. So in the event of a single disk failure, such as by a laser beam, then no data loss would happen because the other disk would have a duplicate copy. Next, we'll talk about RAID 5. In order to use RAID 5, you need to have 3 or more disks. RAID 5, and it can store is not spread across multiple disks. And this rebuilt data disk is used to store parity. It reduces the collective amount of data that can be stored in this array. So for example, if all 4 of these disks were 1 terabyte each, that totals 4 terabytes. But in a RAID 5 setup, the total amount that would be used for data storage would be 3 terabytes. Because the equivalent of 1 entire disk would be used to store parity. And finally, there is RAID 10. And RAID 10 and RAID 0 together. And you need to use a minimum of 4 disks. So in a RAID 10 setup, a set of 2 disks are mirrored using a RAID 1 setup. Then both sets of the 2 disks are striped using RAID 0. So RAID 10 benefits from the fault tolerance of RAID 1, but the downside in capacity for data storage. So if you are using 4 disks in a RAID 10 setup, you can only use 2 of them for actual storage.
Hi students. Coming to our next topic, that is file organization. So let us see how the files are organized. So first, the database is it's a sequence of records. Files consist of sequence of records. stored in sequential blocks in contiguous allocation. So let us take one simple example how the data will be stored in database. Okay, so here you have to be note that a general concept is first what the CPU is there. CPU is the main device who does the processing. So it is having the processing capability. Okay, so CPU first search for data. Okay, it search for data in first main memory. So what is the main memory here? The RAM is the main memory. So it first search for data in main memory. Okay, if the data is not found in main memory, it goes to the hard disk. Searching hard disk. Okay, it's searching hard disk. Hard disk consists of sequence of blocks. Different blocks will be there. Okay, so if the record is found, take that record and it gives to the CPU. Then the CPU will get that record. It reads that record. Okay, so this is a normal procedure. So whatever the data the CPU wants to access, first it checks in the RAM device. If after that it goes to the hard disk and take the data and place in the RAM, and from RAM the CPU will access. Okay, this is the procedure. So always the hard disk will send the blocks to the RAM devices. So it doesn't send a single bit at one time, okay, or a single record at one time, okay, or a single word at one time. So it only transfers a complete block to RAM. So that you have to be noted. So always the hard disk will transfer the block to the RAM. So in that particular block, the CPU will search for the record and take that record and performs the operation. So this is the general procedure, how it interacts, the CPU interacts with the RAM and RAM to the hard disk. Okay. So actually, why we are searching for this? Actually, here the file organization is nothing but the way in which the data is organized in the hard disk. So actually, file organization is nothing but means what it does. Okay, the file organization is a way in which the data is organized. Data is organized in hard disk. So this is the hard disk, how the data is organized in the hard disk and how we are searching.
Yes, ma'am.
Screen is not.
Hard disk.
Screen is not visible.
Yes, sir.
To get the CPU wants the data, how it is going to search a particular record in the hard disk. Okay, and
No, sir.
how it deletes
One second.
and insert record in hard disk with efficient manner. So this point we have to be noted that with whatever the operations we are performing, means the CPU is. So let us see how the files are organized in database management.
Now it's visible, ma'am.
So actually a database is a collection.
Yes, sir.
Okay.
So first, the database is a collection of files. Okay, so files is nothing but it's a sequence of records. Files consist of sequence of records. So each record consists of sequence of fields. Okay, so you are having a database. So in a database you are having sequence of files. So each file is having sequence of records. and each record is having sequence of fields. Okay, so that you call it as a database. So here a database, the file can be stored in different methods. So whatever the file you are taking means a sequence of records in the file. So each file in the database can be stored in different methods. So let us take the data. In the database, the files are stored in sequential. It may be stored in sequential blocks in contiguous allocation. Okay, so in database, the file will stored in sequence of blocks in contiguous allocation. Actually, if you take any other storage device, means the files can be stored in different methods in different storage devices. So there may be a contiguous, okay, non-contiguous, or index allocation. So these are the three different types of allocation. So these are the three different types of storages in the files in database. Okay. So if you take in database management system, the file will be stored in sequential blocks in contiguous allocation. So let us take one simple example how the data will be stored in database. Okay, so here you have to be note that a general concept is, first, what the CPU is there. CPU is the main device who does the processing. So it is having the processing capability. Okay, so CPU first search for data. Okay, it search for data in first main memory. So what is the main memory here? The RAM is the main memory. So it first search for data in main memory. Okay, if the data is not found in main memory, it goes to the hard disk. Search in hard disk. Sequence of blocks, different blocks will be there. Okay, so if the record is found, take that record and it gives to the CPU. Then so this is a normal procedure. So whatever the data the CPU wants to access, first it checks in the RAM device. If after that it goes to the hard disk and take the data and place in the RAM, and from RAM the CPU will access. Okay, this is the procedure. So always the hard disk will send the blocks to the RAM devices. So it doesn't send a single bit at one time, okay, or a single record at one time, okay, or a single word at one time. So it only transfers a complete block to RAM. So that you have to be noted. So always the hard disk will transfer the block to the RAM. So in that particular block, the CPU will search for the record and take that record and performs the operation. So this is the general procedure, how it interacts, the CPU interacts with the RAM and RAM to the hard disk. Okay. So actually, why we are searching for this? Actually, here the file organization is nothing but the way in which the data is organized in the hard disk. So actually, file organization is nothing but means what it does. Okay, the file organization is a way in which the data is organized. Data is organized in hard disk. So this is the hard disk, how the data is organized in the hard disk and how we are searching record in hard disk. So if you want to get the CPU wants to get data, how it is going to search a particular record in the hard disk, okay, and how it deletes and insert record in hard disk with efficient manner. So this point we have to be noted that with whatever the operations we are performing, means the CPU is performing on the hard disk is, it's basically because of the efficient manner, means which one is the efficient. So efficient only it takes that. So the file organization will handle how the data is organized in the hard disk, and how we are CPU is going to be search the record in hard disk, and how it deletes and inserts a particular record in hard disk with efficient manner. That we are going to learn in this file organization. So how many records can be placed in a single block? So first let us see how the file is organized in a database. So let us take, this is a database file. Okay, so this database file consists of set of records. Okay, these are all the records. So each record is having set of attributes. Okay, so roll number, name, age, sex. So these are the fields for those records. So I already said a database is nothing but a collection of files. So in a file it is having set of records, and each record is having set of attributes. Okay. So here this is a hard disk. So I said hard disk consists of set of blocks. The data is stored in the hard disk in the form of blocks. Okay, these are the collection of blocks. The one thing you are noted here, so here you see the files can be arranged in the form of blocks. Okay, so each block is consisting of set of records. Let us say 3 records is one block, another 3 records is another block. Okay, so these you call it as a file blocks. So here you have to note that the file blocks you call it as is logical entities. You cannot see this, it's just as a logical representation. Whereas in the blocks in hard disk is a physical entity. Physical entity. So this point you have to be noted. So this is the database file and this is the hard disk. Here I am explaining how the files are organized in the hard disk. That I am explaining here. So this is one block. So here each 3 records will be placed in one block. So here 3 records in one block, 1, 2, 3, and each 3 records will place in another block, 3 records like that. So the records are stored in the hard disk. And this will store here, and this will store here like that. So this is how the data is storing. The database files are stored in the hard disk. Okay, so this is a general concept how the database is divided into different blocks. Okay, each block consisting of set of records. Here I had taken 3 records, means 3 bytes, and here each block size here I had taken 3. Okay, 3 bytes. Otherwise, you can take more than 3 in hard disk. The hard disk and each block may contains more than 3 also. Okay, so here just I am explaining a simple example by taking the example. So here the 3 records is having the set of fields. Those particular 3 record set of fields will stored in one block, and another block, another set of 3 records is stored in another block in hard disk. So this is how the files are organized in the hard disk. Actually, how many records? Let us see number of records in a block. So here number of records in a block or here is 3. In each block you are having 3 records. This is based on, it depends on 1 block size and 2 size record. Okay, so number of blocks, number of records in a block. So number of records in a block is depends upon the block size, okay, and the size of the record, and the size of the record, that you have to be noted. So the formula for this is to find out, means how many records can be there in each block can be calculated by using the formula number of records or blocks is equal to size of block, right, size of record. So let us take the size of block is 512 bytes and the size of record is 4 bytes, means 128, that is the 2 power 7. Here 128 you call it as records can be present in one block. Okay, so actually I am having the 512 bytes of blocks in hard disk. So here 128 records can be placed in each block. So this is the hard disk. Okay, so in the hard disk, so this is the hard disk. So these are the blocks. So here in each block you can store up to 128 records. 128 records can be stored in each block. So this is how to calculate, means how many records can be placed in one block. Thank you.
Okay, just now you have seen the slide also, and as well as how the files are organized in a record. Okay, and each files or each field in a particular file is having connected with a particular record number, and how it is linked with the other blocks. So these block will be activated once it is called by the particular file whenever it is needed, and the entire set of block will be transferred. Okay, so this is the thing for a file organization. So in the next section we will see the next topic. Okay, pa? Okay, thank you for joining the class.